Hi, I'm Santosh, an aspiring data engineer, Microsoft Fabric certified data engineer, and Apache Airflow certified. I'm going to explain Apache Spark. Apache Spark is a distributed data processing framework used to process big data parallelly across multiple nodes. It is faster than traditional systems like Hadoop MapReduce. Why? Because after each transformation, Hadoop MapReduce write the intermediate data to the disk, which is very slow. It write to the disk and it reads from the disk, which is very slower. So Spark uses in-memory computation. After each transformation, it stores in memory so it can easily access the data and provides high-level APIs such as data frame, datasets, and low-level RDDs and SQL for easier data processing. It supports Python API, PySpark, Scala, Java, R, and Spark SQL. And here comes the Spark architecture. There will be a driver, cluster manager, and executor within the worker nodes. So when you submit a Spark application, the driver starts and creates a Spark session within it. What is a Spark session? Spark session is basically an entry point to interact with Spark. Before Spark 2.0, there will be different contexts for RDD, SQL, and Hive, but the unified interface created is Spark session. It runs on the driver. What it does is it's responsible for managing all the configurations and initializing the application and the handles all the setup and providing data frames and SQL for streaming. So the driver here builds a logical plan and converts it into an execution plan, which is a DAG. Then communicates with the cluster manager. Cluster manager is basically responsible for allocating resources. So the cluster manager allocates executors within the worker nodes for the tasks that were scheduled by driver. So the executor executes the tasks and final results will be sent back to the driver. This is the architecture of Apache Spark. Next, there are different cluster managers of Spark. Yarn Kubernetes standalone. Yarn. We use Yarn in Hadoop ecosystem. When you install Spark on top of Hadoop, you use Yarn. And Kubernetes is a container based. It manages containers instead of physical nodes. We can use it in cloud or Docker. Standalone is Spark's built-in cluster manager for small scale testing and easy to set up. DAG, directed acyclic graph. I told you it's an execution plan. It represents how the data flows. You can see the code snippet here. It reads the data from a CSV file and stores it in a data frame, and then filters it and stores it in another data frame, and then aggregating it and then stores it in another data frame. Finally, it displays. So the execution plan will look like read and then filter and then group by and then show. And there are two stages: read, filter, group by, count. Why there are two stages instead of one stage? Because a shuffle activity a shuffle activity creates a new group. What is a shuffle activity? For example, when you have a 900 MB of data, it will be partitioned into equally. This partition has 300 MB, this partition has 300 MB, this partition has 300 MB of data. Now, when you do a group by, when you do a group by city, I want to group by city. So in a group by city, all the Chennai in all three partition will move to one partition, and all the Bangalore in the partition will move to single partition. And all the Mumbai in all three partition will move to single partition. So the shuffle occurs. The data will move from one partition to another partition. This is the shuffle. So whenever the shuffle occurs, it creates a new stage. So this execution plan is useful for recomputing lost data. This lineage, its record of transformations. This lineage recomputes the lost data instead of storing multiple copies. So it's useful for fault tolerance. Lazy evaluation. What is meant by lazy evaluation? When you do transformations like filter, count, or group by, nothing will happen. It doesn't execute. Only the DAG is created. When you do an action like show, when you do an action, then only the DAG will execute. This is called as lazy evaluation. Thank you.